Hello, welcome to another ATC Doublecut. I'm going to take a look at another ATC blog post. I have one that I did a week or so ago where I put two new videos up about OM246. But first, I want to share something that has been on my mind a lot, which is the accumulation rate of organic matter, or essentially the idea that the more grass grows, the more organic matter it produces in the soil, which everybody knows. Everybody knows that that's the case, but I think it's been hard to put a number to that. And it's pretty easy to put a number to surface area removal. It's pretty, the tine spacing and the tine diameter, and you can calculate how much surface area has been affected and how much area or how much volume has been removed from the green. And it's pretty easy to calculate how much sand has been added. And I think because it's easy to get numbers for those, people will tend to think of how much organic matter has been removed, or how much the organic matter has supposed to have been diluted by sand that's been added. But the thing is, day by day, when the grass is growing, it's always producing organic matter too. And that's something that everybody knows is happening, but I think we sometimes don't try to put a number to it. And I realized I talked about this a little bit in a monologue during the recent ATC office hours with Chris Trittabaugh. And I'm going to play a clip of that where I'm talking about the importance that I think we should put to the amount of growth that we get from added nitrogen fertilizer. Let me play that now. So when you are doing that amount of nitrogen supply, that used to seem incredibly low to me. It used to seem so low to only apply that much for a place like Japan that has quite a long growing season. But when you do that, when you create that type of growth rate, that the type of growth rate that happens when you're only applying 100, let's say 100 kilograms of nitrogen per hectare, you don't have to do so much disruption. The organic matter accumulation rate is relatively low. You don't have to put so much sand. But once you start putting sand and putting coring and doing coring, then you have to have a faster growth rate in order to recover. So it's hard to separate where the cause and where the effect is. That's the clip from the ATC office hours with Chris Trittabaugh. And that's something that's been on my mind a lot recently because, as I mentioned, it's hard to tell which is the cause and which is the effect, because if you are adding more sand, you absolutely have to have a faster growth rate in order to be able to accept that much sand onto a putting green. And that's something I don't really have an answer for right now, but I think it's important to keep it in mind. And I will share the blog post that I want to talk about today. The blog post is called A Crash Course in OM246 Total Organic Matter Testing. And I think this type of testing is a fine way to check what the effect of top dressing has been, to check what the effect of organic matter removal has been. But I think perhaps even more so, it is a great way to check what the organic matter accumulation has been over time. So as I've mentioned many times, I don't think that this is a number that you just look at the test result and then say, that's good or that's bad, that's high or that's low. What you do is look at the change over time. And when you test in 2022 and then you test again in 2023, when you look at that change over time from 2022 to the year of 2023, you will look at four things essentially. You will be looking at how much organic matter was removed by any organic matter removal practices such as scarification or coring. You will look at the effect of sand addition, which has the effect of diluting the organic matter that's there. So if you're doing sand top dressing or filling core holes with sand or filling solid tine holes with sand or doing sand injection with a dry eject or something like that, that would be the effect of dilution. And you're also looking at the organic matter accumulation rate, how that has had an effect because the grass has been alive from 2022 to 23 and it has produced some amount of organic matter. And you also would look at the accumulation rate, the decomposition rate, because some of that organic matter will be mineralized from 2022 to 2023. And what the OM246 test does is it combines all of those and tells you how, taken together, how they have changed at specific depths in the root zone. And I find that to be a very useful number to look at. And in this post that I called a crash course in OM246 total organic matter testing, I was in southern Thailand and I recorded a little video that I hope you'll watch. I'm not going to play it here. I'm just going to describe it. What I did was show some samples that I've collected before I sent them to the lab. And then I went to the post office and sent them to the lab. The interesting thing to look at with these samples is how they're pretty big chunks of material and they're pretty big chunks of warm season turf. I showed paspalum and I showed Tiffical Bermuda grass. Those grasses have thick stolons, thick rhizomes, thick roots, and I'm showing them prior to their burn at the laboratory, and I will try to get pictures of those samples at the laboratory and as they have finished their burn at the laboratory, because I want to show you what the burn at 440 degrees Celsius actually does. It should, if it works the way I think it does, it's going to turn those samples into just basically a clean sand with a little bit of ash. And that ash, once you touch it and just stir it, the ash just disintegrates and it goes into a little fine powder. I showed some pictures there from tests that I've done before. These the pictures that I showed before, that time series, was zoysia samples that I did in 2018. And those were burned at 360 degrees. And I did another set that were burned at 440 degrees and compared those. And the numbers, the mass loss on ignition was almost the same for the 360 and the 440. So you'll get the same test results, the same organic matter percentages basically, if you test at those different temperatures. But I prefer doing it at 440, and the reason I prefer doing it at 440, as you see in the pictures that I showed, is the 440 burn turns all of the material, as far as I can tell, to a white ash. And at 360, there was still a little bit of black charred material remaining. In this crash course, I prepared another video, and that shows the Hazeltine National samples from 9 Green from October of 2021. And those samples were taken from the 9th green with creeping bentgrass, and I show a time series of photos of those samples as they were drying in the office, as they were at the lab prior to the burn, and what they look like after a burn, and then after a burn and stir. And you'll see that what happened with those samples from October of 2021 is they were completely burned and the organic matter is totally turned to ash, which is what we would expect. And that is something that to me is really interesting, because the typical way of doing organic matter is not to work with big samples like this. The typical way of measuring soil organic matter is to first grind up the sample, not to work with it as it comes from the field, and where we would actually measure the thatch and all of the organic material. But the standard procedure for organic matter, as I've shown in some other videos, is to first grind up the sample, then take a tiny little scoop of it after you've already screened out the big chunks, screened out and removed the big chunks of organic matter, the undecomposed living and dead plant material. Screen that out, make sure it doesn't get measured, and then you measure what's remaining in the soil in a very tiny sample. OM246 is totally different. This OM246 takes everything. It says don't do anything to the sample, let's just burn it. But the thing that I want to check, I just want to be sure, because I've seen this multiple times, that when we do send these big chunks of turf and put them in the muffle furnace, it does burn everything, and it does turn it into ash, and it does leave us with a very clean sand after it's done. And I thought, you know, I've got some curiosity about what it looks like for paspalum, what it looks like for Tiff Eagle, what it looks like for zoysia. I'm going to get some more samples, send them to the lab, and do another series of checks, because I want to make sure that the test is doing just what I think it is. I think there's a little bit of a surprise in one of those videos. In the video that I showed from OM246 soil samples before sending to the lab, the one I filmed in southern Thailand, I also showed that I've created some simulated thatch. And I'm not quite sure what's going to happen with this. I made some simulated thatch. I showed that there's a massive difference between sample percentages. And I've done blog posts about this too, about what a huge difference there is when you look at organic matter in the soil on a mass basis or on a volume basis. And I showed in the video that when you do this on a volume basis, let me see if I can go ahead to where that is. Yeah, I've got it here somewhere. Pseudo thatch. I've made some artificial thatch, and this one is less than, this one I label OM33. This is actually less than 33% organic material by weight. So I think I've just played that video, a small section where I showed some of that pseudo thatch, and it turns out to be less than 33% thatch by weight, but the thatch occupies almost all of the sample volume. There's just like a spoonful of sand, and there's like a handful of pseudo thatch, of simulated thatch. So I've got those samples too, which are not actually from a golf course putting green. They're from some, let's call it standard material that I've made, that I want to check and see what happens with those too. So one thing about this blog post is it's kind of like, well, it kind of shows some laboratory procedures. It shows what we can expect for the OM246 samples as they get burned, but also it's a bit of an upcoming teaser for some samples that I have at the laboratory now, and that I hope to get some good photos, maybe even some videos of, to show just how thoroughly the burn at 440 degrees gets rid of thatch, and yeah, burns it all up. That is not a terribly long double cut, but I think that I would encourage you to check out that blog post, which I put a link to in the description and into the show notes. Those to me, those are pretty cool videos that show the samples prior to and after the burn. And they just confirm that the laboratory test is doing just what we think it is, which is getting rid of all of the organic material. It burns off, and from that, you can measure what the percentage organic matter is by weight. I have been working on all kinds of things and traveled to a different continent this week. So I'll be giving some presentations at the Ireland conference this week. And I'm glad to be here. I actually missed my flight from Bangkok, a rare occurrence for me, but sometimes things happen. And thanks to a wonderful travel agent and the many flights that go into and out of Bangkok, I was quickly able to get on a different flight and still got here on the same day that I was supposed to arrive. All right, thanks for watching and listening, and there's plenty more coming up from me for ATC from Galway. I'm Micah Woods.